We now move off the summit of the Greenland ice cap onto the Jakobshavn Outlet Glacier, or a glacier that thrusts ice from the ice cap into the ocean where it melts.
I'm really excited to be out here on the Jakobshavn Glacier. It's just massive. It's just a strange feeling to be out on this ocean of ice that stretches out in all directions. You can go for kilometers and miles in all directions, and you barely go up or down. It's pretty flat around here. We're going to talk to Don Voigt, his 3 grad students, and his compatriot George about why is this glacier moving quickly towards the ocean, more quickly than it's ever moved in recent decades. And it's just zooming towards the ocean, dumping ice into the ocean and raising sea levels all over the planet.
Today was our first day of the seismic experiment that we're running.
Glaciers in Greenland are quickly accelerating faster than we thought they were. And so the reason most glaciers move fast is that they're wet at their bottom. So much like a if you have an ice cube on a tray and the tray's wet, the ice cube will go skidding off the tray. And so Greenland's much like that. Near the margins, there's lots of water getting down at the bottom of these ice sheets, and that's basically helping these glaciers move faster. So ice noise, these little ice quakes, are going to help us figure out how these glaciers are moving past their bed.
Basically, we're digging these holes to get our sensors beneath the surface. This is just a support for the sensor. So we'll put the seismic sensor on here. The idea is this setup will give it better coupling to the ice.
Just done here is we've buried a seismometer, which is going to record small ice quakes that are occurring as the ice flows over the rock at the bottom. And so that's buried now beneath snow. And what we have in this box is just a simple little battery, a little GPS receiver, a little GPS antenna, so we always know what time it is. It's one of the great things about GPS. And then we have just a miniature computer in here that's logging all of our data. And so we're going to shut the lid, and then we'll come back in about 5 weeks, dig everything up, and then we'll hopefully have about 5 gigabytes of ice noise.
Don Voigt uses seismics to try to better understand the layers underneath the ice. They impact the ice with explosives that sends down sound to different layers within the ice. That sound is then reflected back up to essentially microphones that pick up the sound. The length of time that it takes for the sound to be reflected back up can then tell you how deep these layers are, and they can come up with a cross-section of what the Jakobshavn Glacier looks like.
We set up our seismic spread of geophones. We had 48 geophones at 10 meter spacings. Don't want to have to drill any deeper than necessary, and we don't have to want to use larger explosive charges than necessary.
At the moment I'm trying to communicate between this laptop and these seismographs. What a seismograph is it's a recorder of acoustic signals. So we've got a bunch of sensors, a bunch of recorders set out in a line outside in the snow. And as they move up and down, they'll send a signal into these 2 units, and that signal will then be passed into this laptop and recorded.
Alright, well, we drilled 5 holes here, one at 5 meters, 3 at 10 meters, and just finishing up this one at 15 meters.
So we're using an interval of 2 minutes. So every 2 minutes it will initiate a shot. Hugh is down at halfway in the little shack, setting up the recording instruments.
Next interval sounds good. So not in 3 seconds, but in 1 minute and 3.
Roger that.
5. Stop that one. Move on and get ready for the next.
Wow, this is bumpier than heck. This is great. But nonetheless, we had a really productive day, and we got to explore some sort of science that's wild, outlandish, and explosive.
When we use seismic methods to look at the bed of the glacier or internal layers in the glacier, we can get a lot of information, whether there's water there, how thick the water layer is, whether there's sediments beneath the glacier, and even how wet the sediments are.
Because if these glaciers keep accelerating the way they are, that could have large impacts for people in coastal communities, or even small amounts, foot, 2 feet of sea level, could have drastic impacts on their lifestyles. And it doesn't take much of Greenland to do that.
With a little time to spare, we made a short helicopter hop to a nearby camp. While harsh winds pinned us down inside the shelters, we learned from the scientists more about the processes affecting the Greenland ice sheet and the Jakobshavn Glacier.
I'm a climatologist who study the climate interaction with ice. If you go down glacier, more snow and ice melts, and this water runs off in big rivers. It fills big lakes. Big lakes means 2-3 miles in diameter, maybe 20-30 feet deep. And some of these lakes, the water flushes out. And these are called moulins. Moulins are vertical tubes. It's the French word of a mill, because the water turns. The reason why we are interested in moulins is the water that actually flows down a moulin is usually not flowing out immediately. Water is heavier than ice. If you fill a water tube in a glacier, you have more pressure underneath. It can lift up the ice sheet. And that's what we see with our GPS measurements. We actually see that the ice sheet in the summer, where we have a lot of melt, is lifted up a few centimeters and then starts to move faster. And we are studying this interaction of melt, increased warming, and increased velocity, the speed of the ice, which contributes to the increase of iceberg production and increase of sea level rise. Let's look at the next 100 years. And at the current rate, if we have this kind of a loss in ice mass, and if it is not the climate variability, it is a trend as we currently see the last 8 to 10 years, I would predict the sea level will be about 1 meter above the mean. 1 meter sea level rise will move approximately 100 million people away from the coast.
Our bout on the Jakobshavn Glacier eventually came to an end. I'd say that the biggest take-home message from our stay on the glacier is that water underneath the ice is speeding up its progression into the ocean. We then moved on to the town of Ilulissat, near where the Jakobshavn Glacier dumps its ice into the ocean. This is where people see evidence of global warming, and it's not just sea level rise.
Hi, my name is Finn, and I was born here in Ilulissat. and raised here, lived all my life. Most of my cousins and uncles, well, my family are hunters and fishermen, and has always been hunters and fishermen here in this area. My family has brought up many times that you don't have to be a scientist to notice the effects of global warming today. Yeah, what we see behind me is the Disco Bay area, and the Disco Bay area usually freezes in the wintertime totally, that we could drive with a car out all the way over to Disco Island, which is about 100 kilometers from here. But today it's open water the whole year round. I would say about 15 years ago, you could drive with your dog sled all the way up to 1,000 kilometers up north because of the ice. Today it's impossible. What most people are afraid of fishermen, the cold water fish is disappearing, and their equipment is to fish cold water fish. So they're gonna have a big bill in the future if they want to change their gear into to catch other fish.
The ice it's melting. It's getting faster.
I control a crane down the port with the ship. I've been working this factory since I was 13. So I can call myself, okay, I'm a workaholic. It's okay. I can accept that. Temperature is warmer, and sometimes another year, difficult year, there's not too many snow. It's only ground because the weather is changed too much. The ice is coming more faster. You know, the moving ice bear. If for this boat, small boat, yes, it's too many ice, and then twist to small boat to collision. Some people, they say it's okay because it's warmer to have a busy cold day in the ocean, the warm sunshine and warmer climate. Some people they worry about the future. What about happen if the ocean is changed and the fish moving out?
The visit to Ilulissat really rounded out the trip to Greenland, but then it was time to head on home.